Krásné dobré ráno. Funguje ten mikrofon? Krásné dobré ráno. Já vás vítám na ESERO semináři s názvem Země z kosmu v rámci akce, která tady probíhá celý týden, Transatlantic Training, což je vlastně společný workshop ESA a NASA pro pozorování Země. Tak. Já bych vás rád na úvod seznámil s činností ESERO, což je pořadatel toho dnešního semináře. ESERO je vlastně zkratka pro European Space Education Resource Office a my to vlastně volně překládáme jako vzdělávací kancelář Evropské vesmírné agentury. Pojďme si ještě jenom trošičku uvést ty zkratky, čili ESA je zkratka European Space Agency, což je tedy Evropská vesmírná agentura, která má v současné době 22 členských států, mezi které patří Česká republika a právě díky tomu v České republice může fungovat ta kancelář ESERO. A takový častý dotaz, který jsem dostával, a tak jsem se na to připravil, je třeba, co to obnáší pro Českou republiku, že jsme členové. Tak mimo jiné to znamená to, že musíme platit povinně členský příspěvek na roční provoz té ESA, ale zároveň to znamená, že se můžeme účastnit veškerých těch projektů a do těch akcí, které ESA vlastně provozuje, se mohou zapojovat české firmy, takže je to velmi, velmi důležitá účast. A samozřejmě i pro obyvatele České republiky to znamená, že se potenciálně mohou stát evropskými astronauty a letět například na Mezinárodní vesmírnou stanici nebo na plánované mise i do budoucna. Takže je to velmi zajímavá účast, si myslím důležitá, je dobře, že jsme součástí. A kolikže to stojí? Je takový další teda častý dotaz. Tak vlastně celkový roční rozpočet na letošní rok 2022 celé té Evropské vesmírné agentury je odhadován přes 7 miliard euro. A Česká republika do tohohle z toho celkového rozpočtu má letos zaplatit 45 milionů euro, což když se rozpočítá, tak to znamená, že každý z vás vlastně ze svých daní, včetně teda dětí, kojenců i důchodců, zaplatí 100 korun na ten roční provoz té Evropské vesmírné agentury, což si myslím, že je jako smysluplná částka oproti tomu, když se pak můžeme účastnit ty české firmy těch různých vesmírných projektů. Tak. Co patří mezi činnost té Evropské vesmírné agentury, jenom jakoby v rychlosti, patří tam samozřejmě tedy ten průzkum vesmíru, starty raket a podobně, patří tam i pozorování, vesmírná agentura vlastní několik dalekohledů, patří tam, a o tom bude vlastně celý ten dnešek, dálkový průzkum Země pomocí družic, takže o tom se tady nemusíme bavit, to bude podrobně ve zbytku dnešního dne. Pak tam patří samozřejmě navigační systém Galileo, který se momentálně zprovozňuje a už je i částečně v provozu, a samozřejmě účast na Mezinárodní vesmírné stanici. Z těch misí asi jste zaznamenali, jenom bych se ještě vrátil, že teď je aktuální program Artemis, návrat člověka na Měsíc, a Evropská vesmírná agentura se na celém tom programu podílí vlastně tak, že tam dodává takzvaný servisní modul, který bude zajišťovat veškeré životní funkce pro ty astronauty, a výměnou za to právě poletí na Měsíc 3 evropští astronauté v rámci pozdějších misí, asi tak v letech 2027, 8 a podobně. A stejně tak například ještě bych zmínil aktuálně i, že v rámci toho programu Artemis se má postavit výhledově nejen měsíční základna, ale i vlastně jakoby orbitální stanice Měsíce. A bude to podobně jako Mezinárodní vesmírná stanice se skládá z několika modulů, tak 2 nebo možná dokonce 3 moduly na tu měsíční orbitální stanici dodá právě Evropská vesmírná agentura. Co patří mezi činnosti té vzdělávací kanceláře ESERO? Patří tam školení učitelů, pořádání různých takových akcí, jako je například dnes. Měli jsme třeba loni velkou akci, že jsme si volali živě s astronautem z Mezinárodní vesmírné stanice. Patří tam různé takové popularizační akce pro děti, vyvíjíme různé aplikace a účastníme se i různých odborných seminářů. Ta kancelář funguje v České republice už 7 let a je striktně zaměřená na základní a střední školy. Za tu dobu jsme odhadli, že už prošlo tou kanceláří přes 9 000 učitelů s dosahem na 500 000 žáků a vyvinuli jsme 40 nových výukových programů a dohromady jsme nějakým způsobem spolupracovali se zhruba 300 škol. Jak už jsem tedy říkal u těch obrázků, tak tam patří školení pedagogů, pořádáme konference, semináře, dalšího vzdělávání pedagogických pracovníků, děláme různá terénní cvičení, exkurze, nabízíme výukové pomůcky, k tomu se ještě taky dostanu potom u dalších fotografií. Mezi ty zajímavé výukové pomůcky patří určitě gravitační simulátor, mlžná komora nebo třeba rampa pro vodní rakety. Dál se také i zmíním o školních projektech, které jsou tady vypsané a občas pořádáme i speciální akce, například se zmíním o spolupráci s Českou televizí. Tady dole jsou potom naši hlavní partneři, takže spolupracujeme i s Univerzitou Karlovou, s Pedagogickou fakultou Univerzity Palackého v Olomouci, se vzdělávacím centrem Tereza, s ČVUT, s Astronomickým ústavem Akademie věd, s Equilandí v Liberci a celé to vlastně zaštiťuje firma Science In. Seznam těch akreditovaných kurzů na letošní školní rok tady můžete vidět, čili dneska jsme tady v rámci akreditovaného kurzu Země z kosmu a asi nemá smysl, abych to úplně četl, čili pokud až to vlastně dáme na naše nové stránky, tak kdyby vás něco zaujalo, tak se můžete zúčastnit. Vyvinuli jsme aplikaci pro dálkový průzkum Země pro vlastně tablety a nejen tu, i další. A tu si vlastně dneska podle toho programu představíme na závěr dnešního dne. Ona to je vlastně spíš taková jako hravá aplikace pro děti, takže to bude na závěr toho dnešního dne taková jako už nenáročná činnost na to pozdní odpoledne. Tady, jak jsem sliboval ty pomůcky, tak vlevo nahoře je v testovací fázi mlžná komora. Ta je přeci jenom jako taková hezká, ale zároveň drahá pomůcka, takže my bychom vlastně chtěli ve spolupráci se střední odbornou školou na Jarově vyvinout vlastně tu mlžnou komoru za rozumnou cenu. Vpravo nahoře je prototyp odpalovací rampy pro vodní rakety, kde už je v novější verzi. Jestli sledujete náš Facebook nebo Instagram, tak jste si toho mohli všimnout. Dolétá potom ta raketa opravdu jako buď hodně vysoko, anebo když to nakloníte, tak hodně daleko. Rekord máme téměř 100 metrů vysoko, anebo 160 metrů daleko, což už je trošku možná nebezpečné. Vlevo dole je potom ten gravitační simulátor, což je vlastně dřevěná konstrukce s napnutou takovou pružnou látkou, kde můžeme simulovat pohyby planet pomocí kuliček. Je to velmi taková jako zábavná činnost pro ty děti, ale zároveň i jako hrozně naučná. Tak ten už je vlastně hotový, za chvilku dáme nabídku na naše stránky s konkrétní cenovkou a vpravo dole je vlastně od Evropské vesmírné agentury takový jako materiálový soubor na zkoumání různých vlastností materiálů, kde ten si můžete teda zdarma pro školu objednat přes nás. Je tam vlastně sada 6 skupinek dětí. V každé té sadičce je vlastně několik kostiček z různých materiálů, dřevo, hliník, železo, měď a podobně. A je tam k tomu i jednoduchá digitální váha, jednoduchý digitální multimetr, takže v zásadě na to materiálové zkoumání, ať už hustota, vodivost, tepelná vodivost, nepotřebujete mít ve škole žádné vybavení, čili pokud máte jako trošku hůř vybavenou školu, tak je to taková, jako si myslím, obzvlášť, když je to zdarma, taková jako super věc na to základní zkoumání materiálů. Tak, ty ESA školní projekty fungují od roku 2016 a patří mezi ně těchto 5. Vlastně v tomhle týdnu od 12. do 16. září budou postupně představovány novinky těch projektů pro letošní školní rok, takže my zatím na těch našich nových stránkách, které pak později budu prezentovat, zatím těch informací moc nemáme, protože čekáme právě na nové propozice a chtějí tam přidávat ještě nějaké věkové kategorie, takže jsme se rozhodli, že si prostě počkáme, abychom to nemuseli zase hned předělávat. Těch 5 školních projektů patří mezi ně projekt AstroPi, jak je takový ten jednoduchý levný počítač Raspberry Pi, tak jich je několik na mezinárodní vesmírné stanici, tím pádem se to nazývá AstroPi a vlastně je tam několik věkových kategorií a žáci mají za úkol buď jednotlivě nebo týmově vymyslet nějaký zajímavý kód, který se tam potom na tom počítači přehraje. Od opravdu nejmenších dětí, že si tam naprogramují, že tam prostě se přehraje třeba jenom, že tam přejede nápis na obrazovce pro toho astronauta, který to tam obsluhuje, jako dobrý den, jak se máte, až po větší kategorie, kdy tam naprogramují i nějaké měření přímo na té mezinárodní vesmírné stanici, takže vlastně propojení programování s tím vesmírem a zajímavé je, že prostě odměnou pro ty nejlepší je, že ten jejich kód se opravdu v živém přenosu bude přehrávat na té mezinárodní vesmírné stanici. Mission X má podtitul Trénuj jako astronaut, takže to je taková zábavný projekt pro nejmenší děti skoro na celý školní rok, kdy vlastně jejich úkolem je vlastně dělat ty stejné sady cvičení a stejné i nějaké stravovací návyky jako astronauti, kde vlastně ten program sestavili opravdoví astronauti, co prošli nějakým výcvikem, takže je to zase zábavná forma pro ty děti, aby poznali, jak vypadá opravdový výcvik astronautů. A soutěž nebo projekt Moon Camp je vlastně už spíš pro větší, vyžaduje takovou zručnost i práci s počítačem, kdy vlastně cílem je navrhnout, vydesignovat měsíční základnu. Je tam zase několik věkových kategorií a je to vlastně o tom, že se to má i vybudovat s kompletní dokumentací. To znamená nejen v 3D vymodelovat, jak má ta měsíční základna vypadat, jak má být velká a podobně, ale i s technickým popisem, i jako do detailu, jak se tam dostanu, jak tam dostanu ty materiály, jestli si něco potřebuji přivést ze Země, jestli něco využiju z toho měsíce a podobně. A máme na letošní školní rok takový nápad, že ten nejlepší český tým bychom potom ve spolupráci s největší halou na 3D virtuální realitu, která je tady v Praze, jmenuje se Virtuplex. Je to největší komerčně dostupná hala na světě dokonce pro tu virtuální realitu, takže bychom ten nejlepší český projekt převedli do té virtuální reality a pak by se v tom mohli ti výherci vlastně projít tím svým návrhem. Ale samozřejmě nejen oni, i další potom, že tam bude nějakou dobu v tom Virtuplexu fungovat i pro veřejnost potom ta procházka tou měsíční základnou. Soutěž KenSat skládá se ze 2 slov, Ken, plechovka a Sat jako satelit, čili cílem je vlastně do plechovky od limonády dostat malinký satelítek, který bude schopný vysílat data a během své mise něco měřit. Vystřelí se to raketou, od letošního kalendářního roku máme k dispozici raketu, předtím se to vlastně vynášelo letadlem a házelo se ty plechovky se vyhazovaly vlastně z letadla, tak teď už máme raketu, která je schopná vyletět 1 kilometr vysoko. Vystřelí se to vlastně z boku té rakety do stran, ty plechovky a za úkolem je, aby se jim otevřel padák, bezpečně to přistálo. Během toho pádu, vlastně bezpečného pádu, to sbíralo data, vysílalo to data. Musí být i zároveň pozemní tým, který přijímá ta data živě, vyhodnocuje se to, je k tomu zase dokumentace a na základě toho se potom vybírají ti vítězové, čili je součástí jak ta výroba samozřejmě z toho samotného KenSatu, tak potom to zpracování těch naměřených dat a sepsání té kompletní dokumentace. No a vítězný tým postupuje vlastně na evropské finále, kde my máme raketu do 1 kilometru, v evropském finále mají raketu do 3 kilometrů výšky, že vyletí, takže to je zase tomu takovou odměnou, že se někam podívají. Nedávno to finále bylo na Kanárských ostrovech, takže podívám se na Kanárské ostrovy jako vítěz a zároveň můj Kensat vyletí až 3 kilometry vysoko. A pak je tady ještě velmi důležitá soutěž Climate Detectives, ale o té bych vůbec nic teď neříkal, protože o té ještě dneska uslyšíte několikrát opakovaně. Takže určitě pokud vás některý z těch 5 školních projektů zaujal, tak běžte do toho, určitě to stojí za to. Je to podle mě i vlastně takový jakoby kontrast k těm zavedením soutěžím, jako je třeba fyzikální nebo astronomická olympiáda, kde vlastně se jenom sedí a počítá se něco s tabulkama, tak tady se vlastně v každém tom případě něco vyrábí, programuje, píše se k tomu dokumentace a podobně. Tady jenom několik fotek. Tady to je prototyp té rakety, která umí vyletět kilometr vysoko. Tady je záběr potom z toho vypuštění těch Kensatů, čili tam už jsou vidět, je tady vidět několik těch padáčků vlastně. Potom tady záběr i jak je vlastně ta raketa vysoká, je tam vidět uprostřed. Záběr z toho Virtuplexu, my už jsme si tam vlastně byli vyzkoušet procházku tou měsíční základnou, která už je vymodelovaná od kolegy Tomáše Rouska, takže je to opravdu jako nevšední zajímavý zážitek, celkově ta virtuální realita, navíc prostě procházka měsíční základnou, takže to je ten Mooncamp. A ty Climate Detectives budou dneska do detailu. Jak jsem zmiňoval, že naše činnost je různorodá, tak ve spolupráci s námi a s Českou televizí vznikl pořad Komando, který už letos proběhl v televizi. Dá se přehrát z archivu, kdy konkrétně ESERO spolupracovalo na 4 epizodách, každá má zhruba 15 minut a je tam vždycky představený nějaký zajímavý problém. Jsou tam zmíněné vodní rakety, je tam pěstování rostlin ve vesmíru, družicový průzkum Země, nebo jak si jednoduše vyrobit vlastní dalekohled. Je to podáno zase takovou jako poutavou, hravou formou. Možná zase by to mohlo sloužit jako taková třeba zajímavá motivace na začátek pro děti a tak teď si pojďme vyrobit děti tu vodní raketu, kterou jste viděli a chceme, aby to dolétlo výš a dál, než jim to vylétlo v tom filmečku. Takže určitě stojí za zhlédnutí pořad Komando. To natáčení bylo velmi zajímavé, že třeba tady je natáčení té jedné epizody, aby to opravdu vypadalo jako měsíční základna, tak se to natáčelo vlastně dole v jednom kamenolomu, ve skleníku ještě navíc, takže takhle. Jak už jsem zmiňoval, tak vlastně se střední odbornou školou na Jarově, to je vlastně průmyslová škola, kde mají jako šikovné dílny, takže vlastně ve spolupráci s nimi vyvíjíme některé ty pomůcky, jak už jsem zmiňoval, třeba tu mlžnou komoru nebo ten gravitační simulátor. Tady je dobře vidět vlastně ta dřevěná konstrukce na ten gravitační simulátor a naším cílem je samozřejmě, aby ta pomůcka byla vlastně co nejlevnější, takže vlastně v podstatě se to redukuje jenom na nějaký režijní poplatek té škole a vlastně samotný materiál, že tam není jako nic, že my bychom jako si na to hodili nějakou marži a chtěli bychom na tom rejžovat peníze, to určitě ne, takže vlastně díky tady té spolupráci ty pomůcky budou co nejlevnější a zároveň se nám podařilo získat grant, který má název Praha vesmírná, že bychom ještě mohli školám poskytovat na to nějakou slevu, že vlastně máme nějaké prostředky přímo pro školy na nákup pomůcek, takže i s tím vlastně nákupem bychom mohli ještě i v rámci z toho grantu nějakým způsobem finančně pomoct. Naším cílem je opravdu jako dostat ty pomůcky do škol. Potom spolupracujeme právě velmi úzce tady s tím unikátním prostorem, který se jmenuje Next Zone a zároveň máme i dohodnutou spolupráci v jejich dílnách, které jsou také opravdu nadstandardně vybavené, čili kdo by třeba i v rámci třeba výroby těch Kensatů nebo podobně potřeboval, že byste neměli ve školách nějaké své pořádné technické zázemí, tak vlastně můžete využívat tady ty dílny Next Zone zcela zdarma, jenom po předchozí dohodě samozřejmě a mají tam opravdu všechno od obyčejných šroubováčků až pro nějaké lasery a podobně. Takže Vřele doporučuji třeba, když byste měli nějaké zájemce, nějaké kutily na škole, kteří by se chtěli zúčastnit něčeho. No a pomalu se blížíme ke konci mé prezentace, čili my jsme letos o prázdninách zprovoznili nový web, tady je jeho náhled, tamhle je jeho adresa esero.spaceacademy.cz a postupně ho budeme doplňovat. Už tam jsou nějaké základní výukové materiály, jsou tam už nějaké naše akce, které plánujeme a postupně tam doplníme po té, co příští týden budou odprezentovány ty ESA školní projekty, tak tam doplníme vlastně ty ESA školní projekty a dáme tam tu nabídku těch našich pomůcek a všechno, co se bude dít ohledně ESERA, tak kromě sociálních sítí to bude publikováno samozřejmě na tom našem webu. A ten starý web jsme vypnuli, ale protože tam jsou ještě i nějaké jako užitečné materiály samozřejmě z dřívejška, tak je postupně budeme dodávat sem i na ten nový web. Takže to je náš takový jakoby cíl pro ještě konec letošního kalendářního roku přesunout ty zajímavé studijní materiály z toho starého webu na ten nový web a pořádně tady ten nový web zprovoznit. Já vám děkuji za pozornost. Kdybyste měli nějaké dotazy, tak vzhledem k tomu, že jsme začali malinko později a máme tady dva odborníky na tu úvodní pořádnou přednášku, tak já bych případné dotazy klidně nechal do kuloáru. Bude určitě dostatek času během oběda a i potom po skončení celé té akce. Takže jestli vám to takhle nevadí, že bychom živou diskuzi rozvedli potom v kuloárech. Krásný dobrý den, já vítám ještě nově příchozí. Já bych to jenom pro nově příchozí jenom v rychlosti uvedl, čili celý týden tady v Next Zone probíhá konference s názvem Transatlantic Training, což je vlastně workshop zaměřený na dálkový průzkum Země pomocí družic. A je to vlastně společná spolupráce mezi Evropskou vesmírnou agenturou a americkou NASA. A teď tady máme přednášku vlastně od opravdových odborníků. Je tady Francesco Sarti, což je právě odborník z Evropské vesmírné agentury přímo z centra na ten dálkový průzkum Země. A pak je tady doktor Hin, který tady zastupuje právě tu americkou NASU. Bude to jejich společná přednáška, do které ještě občas vstoupí i takovou zajímavostí o České republice kolega Petr Mareš. Ta přednáška bude v angličtině. Požádal jsem hlavně tady rodilého Američana doktora H, aby mluvil pomalinku, čili pokud byste nerozuměli, že mluví moc rychle, tak se klidně přihlašte a zkusíme ho nějak zbrzdit. A jinak je to vlastně taková jakoby popularizační přednáška o tom družicovém průzkumu Země a oni zároveň budou klást i spoustu dotazů a můžete za správné odpovědi dostávat naše nějaké motivační přednášky, teda předměty, čili pokud náhodou jste si ještě nestihli na nový školní rok koupit sešit, tak tam máme i třeba na hraní lodí prostě čtverečkovaný sešit od ESI, takže to se hodí, jakože budete hrát lodě prostě na originální ESA sešítek. Tak jo, já předávám slovo a jdeme na to.
So, hello everybody, dobrý den. My name is Francesco, but you can call me Franta nebo František. Mluvím trošku česky, ale špatně. So I will do the presentation in English. But I could practice some Czech words every now and then. So I'm sorry that we have to do this presentation in English, but of course it's our language, and you may be in trouble to understand some words, because we are not just talking about normal life matters. We are talking about science and Earth from space. So maybe you will hear also some new words that you did not hear in the past. But you can ask questions all the time, and in fact we want to make not an academic lecture, but interactive lecture. So what means interactive? It means that you have to ask questions to us all the time, but we can also ask you questions. So sometimes I will ask you maybe to come here on the stage, or we will ask you questions from there, and we will not go on if you don't answer the questions. All right?
Right. And the student who give correct answers, we will give some stickers. So we only have 7, so yeah, let's see how it goes.
Yeah, exactly. So you might get back home with some presents in the end. All right. So first of all, do you all understand English? Yeah, good. Maybe your English is better than mine, and then I'm so happy. I'm from Italy, actually, so I might have an Italian accent when I talk in English. Her is from the US. She's working in the University of Kent State. Yeah, and we have a different accent, so we are not going to talk with the same accent. So maybe mine is more difficult to understand, or he will be more difficult to understand. But as I say, please interrupt all the time and ask questions when you don't understand, even if you don't understand a word. Okay. Are you shy? In general? Yeah. So we should find out a way, an icebreaker to get friends during this presentation. Let's see how we can do that. I hope that there are also some breaks, some coffee breaks. I hope we are not going to talk for 2 hours without interruption. Otherwise, it will be too tiring for us and for you, and boring also. Okay, so maybe you could start with this one.
See if it works.
Yes, it does.
It works. Okay. Hi everyone, can you hear me clearly without the mic? Okay, so maybe I'll just get rid of it. I think it's better just do without. Okay, so maybe I'll do. I guess it's online recorded, so you need this for the online version. Okay, that makes perfect sense. Yeah, for sure. Okay, wow. So what we're seeing here is a video just shows you where we live. We are living on Earth, and we are living with different landscapes, and including the urban, the forest. What we are seeing here is the change. What has happened in the past a few decades. So we see, for example, here it's an island. We see, from like a okay, it's too fast. But from here, 1985, and we see slowly it's changing all the time. This is Dubai. There are some like artificial island. We see like a palm tree shape. And this video shows you the disappearance of the Aral Sea because of the climate change and also agriculture irrigation. So we lost that lake pretty much. And here, it's pretty fast, but it shows like the expansion of agriculture. And here, we all know that the glacier is retreating, and we're losing, little by little, year by year, unfortunately. So with all this, what is happening on our Earth, why it matters, and how we can measure, how we can track such changes, this is what we're going to talk about today. We are going to use the satellite data to track the past, the present, and maybe from there we can know the future, how it looks like. It really matters because we are living on this planet and we need to know what happened in the past in order to get a better plan for the future, for the next generation, especially your generation. So, okay, I think that's the start of this part, and I will hand it over to Francesco.
Thanks, sir. Very nice. So, you already guessed from the previous presentation that if we really want to have a look at the planet altogether, and you have to understand the planet in its complexity, you cannot do it just from one spot on Earth. Now, if I look around, yes, I can see maybe Arbesow Amnesty, I can see the street, but I cannot understand what's going on in Prague. I cannot understand what is going on in the Czech Republic or in Europe, just if I stand in that room. I have to go a bit higher up. So we started in the past with balloons, then we got vision from the aeroplanes, and then we went higher up. And now, since some decades, we can watch and understand our environment from very far above our heads, so from space, from satellites. And this gives the advantage that we have a global view of our planet, and we can understand also the interaction between different regions and different parameters. So in the very beginning, you could imagine that these satellite images are like pictures, like photos, like selfies of the planet itself, right? Yeah. Uh-huh. So these are some examples of these selfies.
Yeah, so what we're looking at now is a photo taken by the satellite. So can anyone guess where we are looking at? Okay, I saw the first hand. Perfect. Please give it to him. You see, the kids are smarter than our generation, so.
Yeah, so you see, in fact, from this you can understand the Czech Republic. Uh-huh. And this is again for you.
Okay, this one, and so what I was seeing here is two imagery taken in 2 different years. So yeah, 1986 and 2021, last year. So I guess pretty much you know where we're looking at. But what I want you guys to tell me is what kind of differences you see here and why there's such a difference. we can go back and forth to see what are the differences. So any guesses what kind of differences? Well, you know this place better than I do, so I trust you can tell me at least the differences. Hey, Sebastian.
More of the houses and
Homes can be. Can you tell like where roughly? It's close. It's very close. Keep thinking.
Close to this location,
Yeah. It's also a correct answer, I would say. Can you explain a little bit more, like how agriculture become? Like now you see, okay, we have less agriculture, but then what agriculture became? Are they buildings or industry or? Okay, I think that's the correct answer. Next one, Sebastian.
sorry. We mentioned so far photos and selfies because it's what everybody knows. But are these images really photos? Are we just taking photos from space? So when you go to the on an aeroplane and you look at the a region from above, you can make a picture with your mobile phone. And that's a real photo. But do we just take this type of photos from space, or we do something more? So let's see an example. This is, you understand, of course, which region it is, right? That's the Mediterranean. You see Italy. You don't see the Czech Republic, unfortunately. And you can see the sea, the Mediterranean here. But what are these strange colors? What do you think they are? Do they represent if the water is clean or is something else? How do you know that? Yeah, that's true. I should have hidden that. So too easy, too easy. So maybe you will not get the sticker for this one. It was too easy. So in fact, yeah, I wanted to give you a guess. And you see there is a happy swimmer there and unhappy swimmer up there. Because of course, when water is too cold, you don't want to get into water. You know that in Podoli, you had 29 degrees. And you can measure that from space, even if you don't believe that. Of course, you need a very precise, accurate sensor, which is not the case. But we can measure temperature from space, sea surface temperature, and also land temperature from space now. So this is not a photo, definitely. This is another type of information. So when you go up to a plane and you look with your cell phone to the sea, you cannot make this measurement with your cell phone. So what I wanted to tell you is that on satellites, we have very sophisticated instruments which are much more sophisticated than our eyes or our cell phones, and they can measure other things about the Earth which are not photos. So when you go on Google Earth, you may think that you have all the information about the Earth from space on Google Earth. You don't. You just have photos there. But there is much more that we can measure from space. In order for scientists to understand our planet, photos would not be enough. They are important, of course, but they are not enough. So another example here, unfortunately I was too quick. So what do you think this is? Is it potato? Okay, you raise the hand first, yeah? Sorry? So a height map, not exactly. It's not, well, you are not so far away, but it's not a height. Yeah, you? The Earth without water? No, not exactly. Maybe you? Very good, very good. It's a representation of the gravity field. In fact, it's called geoid, and it represents, I will not go into the details, but it represents the Earth gravity. So Earth gravity is not uniform. It's not like a sphere. The Earth, okay, you can approximate it with a sphere, more or less, but it's not a sphere either. But the gravity field definitely is not a sphere. Of course, here it is exaggerated, the shape, but it's not spherical, because also not only because our Earth is not perfectly a sphere, but also because its material is not distributed uniformly. So there are areas of the Earth where the gravity is stronger and areas where it's less strong on the surface. So if you want to make a surface which is equipotential, so where the gravity is the same, you would end up with this strange potato. It's called geoid. And the important thing is that we can measure it from space. There are satellites that can measure the gravity field very precisely. So again, just to show you that they are not photos, it's much more what we can measure from space. So this is very complicated, but you see these different sensors measuring different things, like eyes. The satellite has these eyes. Our eyes measure only in the visible field, but these artificial eyes of the satellite, the sensors, can measure all these different things. The gravity field, the sea surface temperature, and many other things. So we need many of these different artificial eyes on the satellite, and they are called sensors. All right? So, yeah. This was mine, right? This slide? Yeah. Yes. Okay, good. Now, did you ever hear the word remote sensing? Yeah, you did? All of you? It's not a new word for anybody? How do you say remote sensing in Czech? Is there a word? How? Vzdálené snímají. So dálkový means from far away? Okay. Yeah, so like remote. Yeah. So it's the exact translation, literal translation. Yeah. So why is it called like that? So when you measure your temperature, you put a thermometer in contact with your body. So it needs to touch your body, all right? But you can measure the temperature also without contact. Huh? You have seen this type of instruments, I'm sure. Now, especially with COVID, unfortunately. And we can measure the body temperature distantly, without touching the body. So the idea of remote sensing is that you are acquiring information about something, in this case the temperature, but can be anything else, without physical contact, right? So when we went to the airport, if you ever went during the COVID time, they were scanning you to see your temperature. Did anybody got scanned recently? Yeah. So and was it remote sensing? Yes. Yeah, it was remote sensing, definitely. Yeah. And did you ever use remote sensing also in your life? Or maybe today, or in this moment? No? Nobody? Ever? At school? At home? In your life? Sorry? What? The laser, yes, if you have, yeah, you, for example, when you want to measure the size of a room, you are using this type of instrument. Nowadays, you don't use any longer the meter. But now, for example, in this room, is anybody doing remote sensing, you think? Sebastian, are you doing remote sensing now? In this very moment? Yes. You're not watching me then. You're not watching the presentation. So you are doing remote sensing. With your eyes, you are measuring the information coming from the screen. You are seeing me, you are seeing the screen. We are not touching me or the screen, but you can still see it. So your eyes are doing remote sensing without realizing. So we are all doing remote sensing. Yeah. That's a tricky question. I was thinking about that yesterday evening. Should we? So, in a sense, yes, because you are hearing my voice and you are not touching my mouth. But in fact, your ears are in touch with air, and the sound is propagating through the air. It's not like light, which propagates also in the empty space. So, in a sense, if your ears were not in contact with the air, would you hear the sound? So we call it remote sensing for ears?
It is not really remote sensing.
Yeah.
Because the signal we're hearing is not in a format that we call the electromagnetic radiation. And later you will explain what is that radiation.
Yeah. So it's not a real pure remote sensing, but of course it's close to. Now we have a complicated slide. Her even told me that I should cancel it, and maybe I should, but I want to keep it because you must also have something that you don't understand in this presentation. So, but you might understand something. Your eye, I just told you, is doing remote sensing. But what is your eye measuring? Is not measuring the thermal radiation, for example. With your eye, you cannot see the temperature of the sea when you are on the aeroplane or when you are on a balloon. So your eye can only see, what can it see? What type of light? Which? Visible, exactly. So you see, here I put colors. So what you can measure with your eyes, what you can sense, maybe he needs 10 stickers, huh? I'm joking. So we can only see this very little part of the light. Let's call it light. In fact, it's a radiation. What is propagating, which is coming, for example, from the sun, from the stars, through the space, it's a radiation. It is much more than the visible light. Unfortunately, our eye can only see that part of the radiation. And all this, the complete radiation which is being transmitted, in fact, it corresponds to different, how can we classify the radiation apart from the visible? We can classify using the frequency. Did you ever hear the word frequency or wavelength? Yeah? Talking about the wavelength, you see, you have been at the sea, right? Seaside, even if you don't have the seaside here, but I'm sure you've been at the seaside sometimes, and you remember when you are on the beach, there are waves coming regularly. So when you watch the waves, you can measure the distance between the crest of two waves, and that's called wavelength. So it's the distance between the top or the crest of two waves. So this is the wavelength, and you can call it wavelength, you can also call it frequency. If you measure how often a new wave is coming, it's every maybe 2 seconds. So the wavelength is a distance, the frequency is time, right? But it's the same. They are, of course, they are dependent. Not only for the waves in the sea, but also the waves of the radiation can be characterized, can be distinguished with a frequency. So in the same way that I'm called Francesco and you are called Sebastian, also a wave can be named by its frequency. So we can distinguish different waves. Of course, in the visible, we call them green, red, and blue. But outside the visible, we don't have names. So we use the frequency or the wavelength. Is it clear? Or is it complex in this way? I think I managed, hopefully, to explain you the electromagnetic spectrum in a very easy way. I hope so. Maybe it's the first time that you hear about the electromagnetic spectrum, or at school you have seen that already? Yeah, okay, so I'm explaining in a very boring and trivial way things that you already know. Even for you, Sebastian, was it something that you knew already? Good, okay, good, I'm happy. The eye is sensible only to the visible part of the spectrum, or the visible part of the radiation, but other instruments which are on the satellite can sense, can measure other part of the spectrum, other radiations. Okay, that's why we have all those different sensors in the satellite, because they will measure other parameters. And in the same way that the colors give us information about, for example, if water is clean or dirty, on the sea. Other part of the radiation will give us different information. For example, if I want to measure the temperature of the sea, I will not use the colors. I will use the thermal infrared. If I want to look at the vegetation status to see if a plant is sick or is healthy, okay, so there are normally it's true that when a plant becomes sick, it becomes brown. Okay, brown, yellow sheep, the leaves. So you can say visible is enough. Just with my eyes, I can understand if this plant is healthy or not. This is not completely true because sometimes plants are green. I had two different plants. They are both green, but one is healthy and one is not. So to see if a plant is really healthy in the very early stage, I should use this part of the spectrum, which is called the near infrared. So it's just after the red. This is very important. If we have a satellite that can measure the near infrared, I can see from the very beginning if plants are healthy or not, and then agricultural manager or forestry managers can intervene timely to recover the situation before it's too late. Because when the leaves become yellow or brown, it's too late. Plants are already dying. Okay? So that's all. Now, another concept. We talk about remote sensing, we talk about the radiation and the frequency or the wavelength, and now we talk about something else. There are sensors which are active and sensors which are passive. Let's see how to understand that. So this is quite straightforward. The sun is illuminating the Earth during daytime, and therefore, for example, with my eyes, I can see and distinguish the ground. Okay? If I'm looking from my window to the street, during daytime, I will see everything. I can distinguish the different objects. At night, I cannot, because it's dark and there is no light. So what I'm doing, I'm using the sun illumination to understand the environment. So I'm passive. I'm just relying on the sun in order to see. Otherwise, without the sunshine, I cannot see anything. Otherwise, I need to, maybe in Prague, of course, also at night, there is illumination, artificial illumination, so I can see it. But in the nature, I wouldn't see anything. So my eyes are passive sensors. They are using the reflection of the illumination which is coming from the sun, from another source. So this is what also optical satellites are doing. They are using passive sensors like our eyes, and they just use the reflection of the light coming from the sun, and they will record the information and will create an image. These are called optical images. They are like the photos that you take on the cell phone. So that's quite straightforward. Everybody understands that. So the light source in this case is the sunlight. Now, we have seen that already before. So this is the temperature of the Mediterranean. So do you think, okay, it's written there, there are still passive sensors. They are recording now the radiation from the water. So you will study later on at school that every body which is has a certain temperature, is warm bodies emit or radiate energy. So we can measure that, and we can figure out, for example, the temperature of the body. So I asked you the question, but it's already before. We are using this time the thermal infrared, okay? Now we go to a different type of sensor. So all these sensors that I mentioned so far were passive. Either we're using the sunlight, or we are measuring the heat which is radiated by the hot body, but it was passive. Now we go to beyond, and we go to something which doesn't exist, at least in our body, but some animals are doing that. Active sensing, not passive sensing, but active sensing. So the active sensors, they use their own source of illumination in order to measure something. Yes? Sorry? Fireflies? Yeah, what? Ah, so you are anticipating my lecture, so you already see in the presentation. I thought it was confidential information, but you know everything exactly. So the bats are using their own source of illumination. It's not light, of course, but to figure out what is happening in the environment. So I think it's what you were meaning. So in fact, what they do, they at night, they make some shouting sound, and then they see when the sound is coming back. And from the distance between their shout and when the sound comes back, they can figure out if there is a lot of space, a distance between themselves and the cave, or if there is some little animal in between. And they can use this as an information about the environment in the darkness. So they are very smart, and they are doing active remote sensing. So the source of the information in this case is not an illumination, they are shouts and their ears that measure the echo. Did you ever hear your echo, your voice when you go to a cave or some castles? You can also hear the echo of your voice in some chambers. So, okay, you already answered that. And you can also do active sensing, active remote sensing yourselves. You are not a bat, but still if you have a camera with a flash, even at night, you can illuminate the environment and make a picture. So in that case, you are doing active remote sensing. And we do the same from space with some sensor which are called radar. So a radar, this is a radar, a synthetic aperture radar because it creates an image. But you know that the police is also using radars. They are not taking images, but still they are taking data. And what they are doing in that case is to measure the speed of the car and put you a fine if you are driving too fast. So what the radar is doing is sending out a signal, then the signal hits an object, a target, it comes back, and then depending on how long it takes from the signal to go and come back, you can figure out the distance or the speed of the object. Okay, now let's see some examples. You understand what this is, right? What region it is? It's not Czech Republic. It's the place where I come from. So, do you think which part of the spectrum it is? So, which radiation it is? Is it thermal? Is it I don't know? Is it microwaves? And the other question is it a reflection or is it emission? And what is the source of the illumination in this case? Who can answer all these questions? Okay, so some answers are right, some others are not. So it is the visible spectrum for sure. And then you say it's active because it's not the sunlight. Mm-hmm. So remember the definition of active remote sensing is when the instrument is emitting the source of its own measurements. So now the instrument is on board the satellite. This is taken, I think, from the International Space Station, I guess. So, but the International Space Station is not illuminating the ground. So the light is still coming from the ground because this is artificial light at night. So it's not active remote sensing. Well, it's active because it's done by men, but it's not done by the men which are on the International Space Station. So it is still passive. It's just a passive camera. You can do that you could make, ideally, this image with your cell phone if you were on the International Space Station. So remember, your cell phone is passive. It's just measuring the light coming from outside. So it's passive, but it's true that it's the source of illumination is artificial light, so it's passive, it's using visible, and the artificial illumination comes from the cities. Yeah, so you can see that, of course, there are some cities here, like Rome and Naples, and where there are no cities or no houses, it's completely dark. Okay, I will go quick about that, but it's interesting. The satellites, they are orbiting the Earth in the same way that the Moon is orbiting the Earth, and in the same way that the Earth is orbiting the Sun. So everybody is orbiting something else. Did you ever hear about geostationary satellites? Do you know, in the old times, when we were showing the meteo information from the TV, we were showing the Meteosat images. Did you ever hear about Meteosat? No? Satellites. Did you ever see an image of the Earth like that? Yeah? So this is taken from satellites which are very far away from the Earth. They are about 6 times the Earth radius. The Earth radius is about 6,000 kilometers. And these satellites are 36,000 kilometers from the Earth. So 6 times, this is not in the real dimension, it's not in proportion. So these orbits are very far away, and if you are on an orbit which is at this distance from the Earth, at 6 times the Earth radius, is the only orbit where the speed of the satellite is the same as the angular speed of the Earth. So if you are orbiting, if the Earth is here, so imagine that I'm the Earth, and here is the geostationary satellite. So I'm spinning on myself. This is the north-south axis. And can you be a geostationary satellite, please? Now. No, you're not doing that. No. Come closer. Come closer to me. So now be a geostationary satellite. So move. No, move around. No. You are lost. So, Sebastian, come here, please. Yeah, can you watch at me all the time? You should watch my face all the time. You are not doing that. So what do you have to do if you want to watch my face all the time? I'm spinning, I'm the Earth. Yes. So you should go around. The same speed. Faster. Don't fall. Okay, good. So you are a good geostationary satellite. So the geostationary satellite orbits the Earth, moves around the Earth with the same angular velocity of the Earth. So what's happening? So if you rotating about me, so this is the north and this is the south axis. So continue doing that. So he always sees my face. Okay, so imagine that my face is Europe. Then a geostationary satellite which is facing Europe always sees Europe, and you see Europe. Now a day. So this is during daytime, all right? So you will see Europe illuminated, but then after 12 hours, it's night. So now my face is dark. So now you are seeing Europe. So in the same way, if you are watching an image of the Earth from a geostationary satellite, you will see sometimes it's illuminated, sometimes it's half illuminated, half dark, and sometimes it's completely dark, depending on the time of the day. Okay? Was it clear? Yeah. So the only orbit which has the property of facing always the Earth with the same, from the same point, like a fixed point. So imagine it's like if I keep him and then he's moving, it will be the same. But the satellite is not attached to the ground. Still, it behaves like if it were fixed with respect to the Earth. And there is only one orbit which does this. It's the geostationary orbit, which is 6 times the Earth radius. Okay, good. Thanks, Sebastian. Yes, you can see it now. Then there are other orbits which are called polar orbits, and most of the satellites that we use are in polar orbits. So they are much closer to the Earth. They are just 900 kilometers from the Earth. So it's 100 times the height of Mount Everest, more or less. And these polar orbits, they just rotate from the north to the south all the time. And you know how long it takes to make one turn around the Earth, complete in these orbits? At 800 kilometers. So we have seen that with geostationary satellite, how long does it take to make a complete rotation? Oh, sorry, I forgot. How long does it take with the geostationary satellite to make a complete rotation? If it is the same angular speed as the Earth, it must be 24 hours, yes. So at 6 times the Earth radius distance, it takes 24 hours to make a complete orbit around the Earth. But when we are close to the Earth, because we are just 800 kilometers, not 36,000, then the satellite is much faster, because the closer you are to the Earth, the faster you have to be in order not to fall, okay? So when we are on this low Earth orbit, these orbits are very fast. And can you guess how long it takes to make a complete turn? Yeah, you? It's well, more or less. It's 1.5 hours. Yes, depends, of course, exactly on the orbit. Yes, but that's the order of magnitude. It's around 90 minutes or less. So imagine, so in one day they have done maybe 14 orbits around the Earth. So imagine how much information they can collect about the Earth, and everywhere, because the Earth is rotating. The satellite is also rotating in another direction, and then when you combine these two rotations, you are acquiring information everywhere. Of course, there are many satellites like those, so they create a constellation of satellites. These are all polar satellites. Here you have also other satellites, not only polar. So when you combine all this information together with this constellation, you are measuring all the Earth's surface, especially if you wait for 1 week or 1 month, you have really a mosaic of information all over the planet. Now, using all this information from all these satellites, so we have seen that there are many sensors, there are many wavelengths, so many types of radiation, there are many orbits. So when you combine all this information together, we can understand where we are, of course, because we can see very well the geographic features. We can understand if the planet is changing, because if we make, we have seen with her, for example, the images of, was it the deforestation? No, not yet deforestation. Yeah, or Prague from 86 to 2021. So when we combine all this information, we can see how it's changing, and this also gives an idea if the planet needs to be preserved. So in the case of Prague, we just seen the agriculture which is developing. But okay, it doesn't destroy the city of Prague, but there are other places which get destroyed over time. So it will tell us where we should be careful and preserve the environment, and also maybe how the Earth system works. So the Earth is a very complex system. There are many different parameters which are related to the water. So we call it hydrosphere. It means the oceans, the lakes, the rivers, and then there is the geosphere or the land. Then we also have the atmosphere, all the air above us, and not only the air, but many other layers in the atmosphere, and the cryosphere, so all the glaciers. So all these things together change, and they interact with each other. Can you give me an example of interaction between these spheres, for example? Just guess. Yeah, you're the first. Yeah, volcanoes. Yeah, volcanoes belong to the geosphere. So, but of course, during an eruption, they will emit a lot of dust and gas in the atmosphere. So there is an interaction between geosphere and atmosphere. Another example? Rain. Yes, of course. Rain, of course, depends on the meteorology and because of the atmosphere. But then, of course, it will interact with land, because land will become wet, and then water will flow and will go into the ocean through the rivers. So yeah, it's an interaction. Sea level. Exactly. So the geosphere, sorry, the cryosphere, where is it? There will influence the hydrosphere. Yeah. Sorry, say it again. Yeah, the biosphere produces oxygen and then goes into the atmosphere. Yeah, definitely. Or also the CO2 coming from plants, or from also some gases which are emitted by industries or by fuel burning, man-made fuel burning will also modify, unfortunately, the atmosphere. So they will all interact. So the Earth is interacting. There are all these systems which are interacting, and if you want to model that, it's very complex. You want to say? Yeah, sorry, I've been talking for a long time.
Yeah, I think we had to hurry up. Yeah, so what we're seeing, remember that at the very beginning, we saw the changes occurred starting from 1980s, and we see like different change types, like forest loss, also like urbanization, and this is from the satellite called Landsat. So this is a NASA asset, and it started in early 1970s. So this year actually is the 50-year anniversary of Landsat. And this is probably the most widely used satellite to monitor the changes on Earth, because there's no other satellite that can provide a global coverage like Landsat does over the past 50 years. There's also the other satellites, but they cannot see it well as Landsat. And it's not only just one Landsat. So you see from 1973, there's Landsat 1. And then we have Landsat 2, Landsat 3, Landsat 4, but not the Landsat 6, because unfortunately the rocket didn't really work. So the satellite didn't go into the orbit. So we often, you know, we feel like sometimes granted that, oh, we have satellites, but actually there's also so many risks in order to get the satellite into the orbit as it is supposed to be. And also, even though the satellite might be on orbit, but it could be also a lot of technical problems. We might lose the signals, etc. So it's actually really challenging to get really good photos of the Earth from the satellite. And I just want to highlight the Landsat. So probably in the future, you will still see some, you know, very beautiful imagery showing the changes of the Earth, and very likely they come from Landsat if you are seeing the pictures in the 1970s or 1980s. The next one.
Thanks. Yeah. Good. So now we talked about many concepts, and we talked even about difficult concepts like electromagnetic spectrum, radiation, frequency, wavelength. I hope it was not too much. Now we will see some images, so it will be more pleasant. But still, I hope that you can retain the information about the physics that we gave you so far to better understand the examples that will come. Was it too heavy so far? Was it boring or too difficult? Are you tired? You would like to see some examples, or you would like to have a break before? Petr, maybe you can tell. Now we have just images. Okay, now I can show you 1,000 examples. I can show you 20 examples. You tell me how much time we have. So yeah. And then we can continue. So after the break, can I continue, or we go to the experiments? Okay. Yeah. So I will just show you maybe. So then I will show maybe 5 minutes of examples, and then we will do the coffee break. All right. Good. So I divided the examples according. We have seen that there is the land, there are oceans, there are cryosphere and atmosphere. So I try to follow the same schemes for the examples, but of course some of the examples are mixed. So as you correctly said, when we show volcanic information from space, it relates to the land, but also relates to the atmosphere. So many examples are also mixed. So this is these are optical images taken in the visible, and they are very similar to what you could see from an aeroplane. It's just taken from higher above, and these images are very easy to understand, but they have the disadvantage that when there are clouds, you don't see below clouds. All right? So you have to wait that the clouds go away, or you have to make many images and wait there are no clouds, in order to have a clear view of the landscape. But when you have enough images, if you have thousands or millions of images, you can eliminate those pixels, so those parts of the images which have clouds, and you can create a mosaic with all the nice pixels without clouds. So you can end up, after maybe 1 year, with a complete mosaic of the Earth, starting from these images, eliminating those days when you have clouds. You can measure in this way easily, using these visible images, forest fires, because you see the smoke, for example. These were forest fires over Portugal. You know that nowadays, especially during summertime, because of the heat and because of the higher temperature, the ground tends to become drier and drier, and we have fires, especially in southern countries of the Mediterranean region, but maybe also in Czech Republic. Is it a common problem here in summer to have forest fires, or not so common? Not so much? Sorry? Sometimes, yeah. In Spain, Greece, Italy, and southern France is a very bad problem. Also in California, and not only California, yeah. And sometimes these are natural because they depend on the fact that the ground is very dry and the vegetation then has a stress because there is not enough humidity. Sometimes there are people that profit from the situation and put up fire because they want to have, they want to get rid of forest and to build there something in the future. Yeah, this is Los Angeles and San Diego. Okay, these are old examples, but the same things are happening every year, every summer, unfortunately. And this is not a visible image anymore. This is something else. So this is okay, the Black Sea, the Caspian Sea, and there the point there that I mark is Moscow. So what do you think it might be, this image? It's not visible. It's not the color of the ground seen from the satellite. It's another parameter that we are measuring from satellite that I have not mentioned so far. I told you that there are many sensors, and this measuring something else. Pollution? No, it's not about the atmosphere. It's really about land. It's a land parameter that we can, another land parameter that we can measure from space. So it's not pollution, it's not atmosphere, it's something related to land. What could it be? Sorry? Type of land? No, no, it's not the type of land. It's not the classification about land type, land cover, no, no. What you say could be? No, it's not the density of population. So let's see what happens during time. You see, those eyes, so sorry, they shouldn't go there. Gosh, too quick. So you see, this is how I'm lost with this. So now you know what it was. So this is something we developed over several weeks. It's southeast of Moscow, and in fact it's the soil moisture, or the opposite of soil moisture, which is the drought. So when it's very yellow, it becomes that the ground is becoming very dry. And we can measure the drought or the soil moisture from space using some specific sensors. So why is it important? Because if you see that the soil moisture is disappearing, so it means yellow appearing means that the soil moisture disappearing, or the drought is becoming strong. So you see, the drought is becoming stronger and stronger. So when over several weeks the ground becomes very dry, then it is dangerous because obviously the vegetation will suffer. Maybe the trees will die, or the vegetation will die, and then it will be very easy to develop what? What can happen if there is a drought over several weeks in a forested area? Fires, yes, exactly. And in fact, this is exactly what happened. Okay, here I don't have the image of the fires over close to Moscow. You remember that some years ago there were these fires close to Moscow that developed exactly in that region, and even in Moscow it was difficult to breathe because of the smoke. But we can measure this drought, and we can measure also the forest fires from space. And we can create maps of forest fires. Of course, this is over several months, and you can do that also several years. So we can measure the drought, or the soil moisture, and the fires. Of course, the soil moisture or the drought is a preliminary, it's a precursor, it's called precursor, of the fires. So when you see from space that there is a very long and important drought over a certain region, then you should warn the civil protection that forest fires might develop there easily. Any questions or comments? No? Is it understandable? I think so. Is it yours?
Should we take a break or continue?
Maybe we can just show this and then we make the break.
Okay.
Is it a video? Yes. Just this video.
So what we're seeing here is also NASA assets. It's called like, you can see the lights. So it is, the light we're seeing actually, it's not only about population. So of course, in the bigger cities, we have like more lights. So this is the sensor you just saw. But actually, well, of course, first we see like, Paris and this east coast of the US, and we see the Chicago close to Lake Michigan. This is a classic example. You see South Korea, so many lights. North Korea, none. But also at the side, it also shows the activities. For example, we see the Nile in Egypt, and we see like along the river because of the boats and etc. And so this is India. It also shows that a lot of, you see the linear features, they are the road. So it does not only show the population, but also show the economic, social activities. Yeah, just this year we will release the first daily night. So which means that every day we will get a photo of the Earth, and every corner of the Earth, the light, how it looks like. This is super important. And later I will use some examples to show how we can use the night light to monitor some changes on the ground. Yeah, that's about this.
Thanks. So I think now we could go to the coffee break. We hope you are not too tired. More or less, we are almost finished with this part because we've shown you all the main concepts. We have a few additional examples that we'll show you after the coffee break, and then we will start doing some experiments. So it becomes really interactive, and you can measure, you will see how you can measure the air quality. Yeah, please. How long will it be today? The break. Petre will... 5 minutes only. Oh. Yeah. Maybe 10 is more realistic. Yeah. 10 minutes. 10 minutes, is it correct?
Okay, the pointer don't work. Okay, this one work. What is this? $10 looks like it's going to shut down. That's what I understand. Oh, how to go back? Do you know? Which one to go back?
This one.
This one. Okay,
Yes.
I see. Great. I feel like the countdown is just like when we launch a rocket to the space, we count down, okay, 10 seconds left. So I want to spend a little bit of time to talk about more about how we can engage. I mean, you guys can engage with some NASA projects, for example. So NASA, together with other agencies in the United States, they have a program called GLOBE. So have you guys ever heard about this program, GLOBE? Okay, so this is an integrated learning environment that is dedicated for the education in environmental science. And this is really big program. So from the name global, you know that it is at a global scale. And so anyone can participate. And they also have a special programs designed for the teachers and the students, either at the primary school or the secondary school. So you can go to the website www.global.gov, and then you can get all the information there. So what the Globe does, the Globe encourages the students to collect information and upload this information to the website of a Globe, and then all this data will be used by the scientists for research. So in other words, you are doing the research, you are supporting the scientists to do the NASA project, which is really valuable, because all the information you collected will not be just, experiment. They will be used for the real work. And this is just one example. For example, this in the past 7 days, there are some measurement of the temperature, and you see from different locations. And so all the users can collect the data and upload the data to the data portal. So again, the website, the link is called globe.gov, and you can check it. So this is really cool program, and it exists in more than 100 countries and more than 38,000 schools, and also the teachers. So this platform has really, really detailed instructions to the teachers and also to the students, so the teachers can follow exactly the protocols, how to collect the data, how to upload the data to the website. And there's also mobile app of this program. So relevant to us, remote sensing. So that's not, well, as I said, so this program covers almost everything, including the climate, the water, the soil, but also since it is mainly sponsored by NASA, it has a really strong component in remote sensing. So for example, you can go outside and take your cameras and see, oh, actually this is a busy street, or this is a river. And then you can upload such information to the website. This is really valuable to us because if we want to know the Earth, we need to know what they are. If we look at satellite imagery, yes, we can roughly tell, but we still need to know the ground information. We call it the ground truth. So that's why we need you guys, to tell the scientists what exactly they are. And so that's also, this is one recent challenge called the Land Cover Challenge 2022. And once you finish that, you can get a really nice certificate to show that you have participated in this program. But what is really awesome about this program is every country, the participating countries, have like a regional office, a regional hub. For example, if you go to the website, www.global.gov, and then you can select your country. So there's one country for sure, Czech, and it's incredible because more than 200 schools in Czech Republic have participated in this program, and they are super active. And I was told by my colleagues that the Czech Republic is probably one of the most active countries in the world that are participating the globe. So I encourage you guys to check it out, and also later we can talk a little bit more about how your schools can participate in this program. And so, as I mentioned, that it's really active, and over nearly 1 million measurement has been submitted just from Czech Republic. So this is really impressive, and they have regional office. I think the person who is the point of contact in Czech Republic is Mr. Jan Blizek, and I have also his contact information, so I will share it with you if you guys want to contact with him and to see how your schools can participate in this program. Okay, so this is one video. I hope it works. Okay, great. There's no sound. It should be, but you can read from the subtitles. So this video shows you how the students in Czech Republic, how they participate in a global program. And this one is more about the collection of the environmental data. For example, like the water quality. All this like equipment and protocols will be provided by the program. And yeah, the data will be uploaded eventually to the website. Yeah, so this is another one, like the phenology. We call the phenology, which is about, okay, so I guess we are running out of time here, but yeah, we can talk more after this session, and I would be happy to connect you guys to Mr. Yang in Czech Republic. Okay, we have to move on. So I will go back to the presentation left. Sorry, I think this shows up too early. Okay, you basically already see the story. So we saw it already, what it can do with the satellite during the night. We see that different cities. So this one shows you Ukraine. It's hard to tell because right now there's no any labels there. But if we see what has happened 6 months after. So the first one was taken by the satellite in the night. Remember that I just showed you that the satellite can capture the signals in the evenings, then we can see the night light. So this one was taken this year in February. And we see Kiev there. And then if we see the same places, but 4 months later, which is June this year, and if we go back and forth, we see a huge change. So this is because of war. Because of the war, we lost Ukraine lost a lot of population and also a lot of power. So this is a classic example to show how we can use night light to track the changes due to the societal change. And also this is another example to show you how the night light imagery can be used to monitor what has happened due to the armed conflicts, which is a war. So this example shows you Syria. We all know that in the past 10 years, there's a lot of changes in Syria because of the Syrian civil war. It has been more than 10 years. So if we see what has happened before and after, we see a lot of loss of the night light in Syria. But here, my question is, how about Baghdad, the capital of Iraq? What do you see here, and why is that?
The lights went more to the center and away from the Syria.
So you think there's, so we see here like more lights. So your theory is because the people fled to Baghdad, or why is that? They fled. Okay, this could be one reason. Another explanation? No? Yeah, so I think your answer is partly correct, so please give this to her. And so there are two reasons. The one reason is the population, they fled there. And the other reason is because there's also expansion of the oil. So what happened here is a lot of population fled to Baghdad, but also because the war, which is the terrorist activities have been largely suppressed. So that's why there's also a lot oil, field oil facilities started running again. So that's why we see the expansion of the light. And we often see that a lot of light loss due to this. This is a classic example of how the war has damaged our city, which is really, really sad because it created a lot of problems, for example, like the refugees. And we know that there was quite a few refugee waves and they fled to different places, especially Europe. And so this is one imagery shows us a village in Syria. And we call it a very high resolution imagery. And you can see this actually from Google Earth. They have all this imagery like this, and which is different from what we saw earlier. Because here we can see really, really clearly what it is on the ground. Like we can even see the single trees. And so this is one type of the satellite that we call it very high resolution. It's just like your phone, right? You have a really good camera, then you can see more details and better photos. So this is probably the most clear picture we can take from satellite, which is a very high resolution imagery. So again, if we see what has happened before and after the war, and we see clearly after the war, and we have a lot of just ruins because all the houses pretty much they got bombarded, and that's why there's no houses left there anymore. So, okay, so here's another example to show the damage of the war. So I want to ask you guys, what have you seen here, and what are the reasons for the things you see from this picture? For example, what are the black things, black color stuff, what they are? Can you make a guess? Okay, I'll ask you. Can you say it loudly? Burned, correct. So here you go. Yeah, so it is a fire scar, so because of burning. And so all this burning actually, they are not accident. So they're caused by ISIS. If you read the news, you know there's extreme Islamic groups, and actually they are not allowed to, well, in any wars, there's a law saying that you cannot target agriculture because agriculture is the only thing the local farmers rely on. Without agriculture, then we don't have food. So that's a clear international law doesn't allow any attacks against the farmer or agriculture. But ISIS, they still do it anyway. So this is another value of remote sensing data. We can use it as a reference to see who is against the law. So this is really valuable information because satellite doesn't lie. It provides a really subjective, objective information. So that's why it is often used by the government to know, well, okay, if someone is against the law or not. Okay, deforestation. Keep going. So deforestation often probably is one of the biggest changes on Earth together with urbanization. So we're losing a lot of forests due to the clear cut like this. So this is because there's oil palm plantation. And the oil palm plantation is used to get the palm oil. So one can give me 3 usages of palm oil. What the palm oil can do, how we can use it. Can anyone give me at least 3 usages of the palm oil? Yeah. Sorry, can you say it again? In food, yes, at least 3. So you give one. Grapes? Creams, yes. And another one. Use as a gas, yes. Here you go. So actually the... Oh, okay. Yeah, well, I shouldn't give out the answers. Yes. So it can be used basically in everything, pretty much. Everything you see, pretty much. From detergent, from the ice cream, and from the pizza, and from lipstick, and from the soap, almost everything. and it's also cheap. So that's why we have a lot of cuttings of the forest just in order to grow oil palm, to get the oil palm oil for our product, for all the products we use. And this is unfortunate. And because can anyone again give me some answers? What are the consequences of the deforestation? At least give me 3. Less life, yeah. 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 That is correct. So last sticker goes to you.
Repeat the answers because you will go in the streaming and everything.
Okay. Yeah, so there's a lot of damages of deforestation. So one is we are losing the wildlife. And the other one is we are also causing climate change because, as you said, the forest can absorb CO2. And if we are losing the forest, then we will have more CO2 in the atmosphere. And then, of course, we will have the global warming, which is unfortunate. There's also the other services, like, the forest can, for example, provide, can provide also, for example, to maintain the soil and the water, so we will not have the erosions. And also, we often then go to forest, for what? Just for fun, We like to walk in the forest. And then if we are losing in forest, then of course, all this kind of like, we call it ecosystem services, which is the, the functions or the good things provided by the forest will be lost. And it's really unfortunate because it's happening in many places. So for example, next one is Amazon. And in Amazon, the story is we cut the forest in order to provide soybean. The soybean actually is widely used to feed animal stocks. So that's why a lot of people, call out like for the consumption of the beef from Brazil. So saying that, we shouldn't eat too much beef, or we should only eat the beef that is like environmental friendly produced. This is because a lot of beef they are fed by, using the soybean, and the soybean we produce that on the cost of the forest. And as you mentioned, that if we cut the forest, then we lose a lot of wildlife. So for conservation, losing the forest is really, really bad news. And also the climate change is due to the forest loss. We are getting hotter and hotter, and partly because we are losing forest. So this imagery shows you, again, Landsat from the NASA assets, and how we see, what we are seeing here is how the forest, we are losing it like year by year. So it's quite interesting, we see like a pattern like this. So this is actually, that's a main highway. So because of the transportation in Brazil, in some really remote areas, it's easy to cut the forest, right? But you have to get the timber out. So that's why a lot of deforestation occurred close to the highway, because then the highway can easily transport the timber out of the remote areas. So that's why we see a pattern like this. So the deforestation just happened along the highway. And also another example is burning. Burning is also a good way to get rid of forest. They do not care much about timber. They only want the land to cultivate the soybean, for example. And you see, we see the smoke, and Francesco already showed you some examples about the fire and also the smoke. This is another example. And so this imagery exactly shows you a fire that happened, I think like 4 years ago, probably in California. So in California, we had a huge fire. We call it Paradise Fire because it happened close to a little town called Paradise. And I still remember clearly that when it happened on the same day, I have a friend who came into my office, and he looked really, really sad. And I said, "Hey, buddy, what happened? Why you look so upset?" Then he told me that my parents' house was just burned down, like literally, like, less than 1 hour ago. And I was really, really stunned. And then NASA quickly produced a lot of maps, as we see here, and to show like how much fire has expanded and how many houses has been burned. So the satellite imagery is really, really powerful to monitor the natural or human-made disasters, because then we can see what happened, and then we can make a plan. Okay, so this town has been all burned, and then we maybe need to allocate some resources to rebuild this town. So the satellite imagery is not only about providing the information about what has happened, about the environment, but also it is really widely used for decision making for the policy. Okay, so I think I will hand over to Francesco.
Okay, thanks, sir. Unfortunately, we have so many nice examples to show you, and it's not possible because the time is run out. But I hope. Is it possible then to just put the presentation, because there was one last slide that I wanted to show, only one slide of the previous presentation, if it is possible, just one, the one here, and then we go to the atmosphere. So we have seen many different examples. So from space, maybe when you came here this morning, you thought that what we could see from space, the satellite images which are on Google Map. And in fact, it's true. They are taken from satellites. If you go back to 10 years ago, 15 years ago, yeah, from space you could see just those type of images. Now there are many more. Sorry, we just go back to the. Okay, 1 second. This is just one single slide that I want to show you, and then we go to the atmosphere. Yeah. Okay. So from space, you can see not only the satellite images, the maps of the Earth, but many more things. For example, this is my last slide, and we go to the atmospheric remote sensing, because you are going to see yourself how to measure air quality. So this is the last thing I wanted to show you, is that from space we can measure even something that you could never guess, I'm sure, is the displacement of the ground. When, for example, there is an earthquake, or where there is a landslide, or where you are pumping gas or oil or water from the ground, the level of the ground is changing, but it's changing in a very tiny way, just a few centimeters, sometimes just a few millimeters. So you say, who cares if the ground has moved a few millimeters? Actually, it's very bad, because if there are cities, if there are bridges, if there are buildings, they can have cracks and they can collapse. This is what's happening often when there are the underground construction in the cities, because of the new metro stations. They have to pump water from the ground, because otherwise it will get flooded. And when you pump water from here, then maybe the water is coming from there. So there, the ground is going lower, because I'm pumping water, and then there will be cracks in the buildings, and the buildings may collapse. That happened in Paris. So from satellites, which are 800 kilometers above the Earth, 800 kilometers, we can measure millimeters of displacement in the ground. And this is the region of Rome. So as Petre told you, there were some talented students from Czech Republic that came to Esrin a few years ago, and then we went and did the kayak in these lakes. It was very nice. And this looks like a lake, but in fact it's an ancient crater. It was an ancient volcano a very long time ago, and then this region is still going up. It's growing up because it's still volcanic areas. And the displacement here, the uplift, is a few millimeters per year, but we can measure it from space. Here it's Rome, and then there is the river, like a Vltava, and then the river is taking away some sand, and this sandy region is slowly going down. So red means that it's going down. Blue means that it's going up. So these measurements are very important over cities, over infrastructures, because they can be precursor of important cracks, important events, which could be important for buildings in the future. So even this information can be collected from space. So the main message of this presentation today is that from space, not only we can see the geography, of course, which is important, but almost, well, there are thousands of different parameters related to the Earth that can be measured from space, and it's not so something that you could guess in the beginning. I hope that you got some new information from this presentation, and that it will develop your curiosity to work in engineering or in physics when you grow up at university. So here you have some brochures of the, I don't know if it's Charles University or Technical University, but in Prague there are many subjects that you can study at university which are related to space, and that can help us develop new algorithms, new techniques, new data in the future. And we really need young people like you to develop these things further. And you may have read on the newspapers that there are so many new satellites being launched, so I'm sure there will be a lot of new professions and jobs also for people who are active in engineering and in physics at university. Good. So the last thing, you know that now today there is a program to use maybe you can ask your colleagues to move to the other presentation. We will do now some remote sensing of the air quality, but in situ, not from space. So we have brought some experiments, some instruments that will allow you to measure the air quality in this room, or we can do it outside and measure the air quality in the city. And this is, of course, it's not the same as measuring the air quality from the satellites, but the principles are the same. So I asked you before if you were doing remote sensing yourselves, and we are doing with your eyes, partially with our ears, but we will do now real remote sensing with an instrument. This is called in situ measurements or on-site measurements, because we are doing here. And of course, it will not be the same measurements, not the same data that you will get from 800 kilometers above. Good. So this is the representation of the atmosphere. The atmosphere can divide it into layers. So this is the ground. And of course, what is most important to us when we breathe is the troposphere. So the troposphere are the first kilometers of the layer. So we are talking about a layer which is, I think, about 10 kilometers from the surface, and it's where the most of the components of this layer are nitrogen and oxygen, and only 1% are other gases, like CO2. You know, CO2 is very important when we breathe. We develop CO2, and if there is too much CO2, of course, we have problems to breathe. But there is also argon, water vapor, most of it in fact is water vapor, and traces of other gases, aerosols and clouds. So they have a lot of effects. So one of the effects of these gases or water vapor in the atmosphere is the greenhouse effect. Now everybody knows about that, because you read on the newspaper that greenhouse is responsible for is potentially responsible for higher temperature and increase of temperature on our planet. And what happens is these gases trap the heat coming from the sun. You see that the heat is coming, and then it's not going to escape because of these gases. So the temperature will increase. And the main gases which are responsible for this greenhouse are carbon dioxide, CO2, methane, NO2, and water vapor. So how can we measure these gases? We can measure it on ground, thanks to some experiments, some instruments that you will get now and you will be playing with. This is it's called AQP, Air Quality Platform. It's developed by ESA, specifically for schools. And I think that some schools in Czech Republic are using that already. But we can also measure it from using remote sensing. You know now what remote sensing is. And so we can measure those gases also from space. The difference is that, of course, when we measure it from space, we are 800 kilometers above the Earth, so the concentration of the gas is not the same. If we measure CO or CO2 here or on the satellite, you will get different measurements, because, of course, there is a huge column separating us from the satellite. So the measurement, the concentration will not be the same. yeah, there is a specific satellite which was developed by ESA in cooperation with the Commission. It's called Sentinel-5P. These sentinels, I did not mention to them, they are called sentinels because they are monitoring our environment all the time and the Earth. So they've been specifically developed in order to monitor the state of our planet. And one of these is called Sentinel-5P, and it's measuring those parameters of the atmosphere which are very important for human life. So NO2, ozone, methane, carbon monoxide. Did you hear about the ozone and the ozone hole? Yeah, you know about that. Eh? So it's a very important gas in the atmosphere because it protects us from the ultraviolet. So it filters the ultraviolet radiation from the Earth, so from the sun. And when this gas is becoming too rare, so there is not enough concentration, the ultraviolet concentration will become too high. And this is happening especially in the South Pole, where, for example, there was a time over Argentina, southern Argentina, when the concentration was so low that people should not go out in the sunshine, otherwise they would get too much ultraviolet radiation and they would get burnt. So during coronavirus, of course, during the lockdown, some of these gases produced by fuel burning were reduced because there were less traffic, less cars in the street. So this was a positive effect of coronavirus, if we can talk about positive effect of coronavirus. So this is the variation of one of these gases, is NO2 in particular, before and during the lockdown. You see that there are regions like Milan, the Po Valley, where there is high concentration because of the industries and also because of there is not so much air circulation on the valley, but during the lockdown it became much better, so much lower. Another gas that we can measure from space is the CO2, and of course you can see these are yearly variation, and of course every year between summer and winter there is a cycle, but if you look at the average, you see that this is measurements from 2003 to 2017, but in average it's always increasing, unfortunately. So this is quite worrying. And this contributes to global warming. So definitely global warming because of the CO2 is increasing because we can measure it from space. Another important gas that we can measure from space is carbon monoxide, and this is produced by, for example, by cars. And it's odorless, so you cannot feel it, but it's very dangerous because it can poison your lung. And if you are in garage and you switch on your car with the door closed, in this way you could die. There are people that suicide in this way, so it's a very dangerous gas. And another one, this is the last one that I show here, is the particulate matters. So these are like dust in the air. And when it's very little, so the PM2.5 and PM10, this is depends on the size of these particles. It's very dangerous for our lungs. So some are natural, some are man-made, and what is called PM2.5 are particles which have a diameter smaller than 2.5 microns, and PM10 is less than 10 microns. So especially the small one, the 2.5, is particularly dangerous, and because it can really go into our lungs and penetrate into the cells. And they can get to cancer or respiratory diseases. So it's very important to measure these parameters, especially in cities where there is dense population, in order to warn, for example, the municipality if the concentration becomes too high. So now we will move to this experiment where you will be able to measure yourself some of these concentrations here in situ. And then, of course, it would be interesting to compare to similar parameters in space measured via satellites. So in the exercise that you will see now, I think Petra and Amalia will run this AQP, so these instruments where you can measure some parameters like CO2, CO, NO2, etc. And then you could upload these results on a web page, and you can compare with similar results obtained by other students, other schools in other cities of Europe. Yeah. And then after that, maybe Amalia, if she has time, will show you how to retrieve similar parameters from space using Sentinel-FIP. So there is a free, so you don't have to pay, website where you can retrieve the Sentinel-FIP images from space, and you can measure, for example, the concentration of these gases over the Czech Republic today, yesterday, or last week, and you can see also how they change with days and with time. That's all. So.
Thank you very much, Francesco. It was great to have you here. Nemusíme spěchat, domluvili jsme. Já ještě předtím, než teda bude oběd, který teda taky máme připravený pro vás a můžete si ho tady užít, tak ještě ukážu krátkou prezentaci, nebo řeknu pár faktů, proč je dobrý v České republice sledovat kvalitu ovzduší. Můžu poprosit o prezentaci. No, co myslíte, co je největší zdroj přístupu škodlivin do lidské populace v Česku? Nebo v Evropě dokonce, ve světě už úplně. No, je to znečištění z domácího vytápění, hlavně teda v Česku a na východ od České republiky. Tady vidíme jeden komín, který kouří za večera, kouří třeba 5-6 hodin, když se večer zatopí. Can I have the Samozřejmě ten komín v tom rodinném domě není sám. Okolo něj bydlí jiní lidé a když ten komín kouří, tak dokáže zanést třeba údolí obce takovýmto způsobem. Když jsou ty komíny 2, jsou všechno ukázky z posledních 2 let v České republice. A ta obec je údolního charakteru, třeba ještě orientovaná třeba jako severojižně, takže neprofukuje těma západníma směrama proudění vzduchu a třeba za inverze opravdu zůstává uzavřená, to, co si do ní ti lidé nakouří, tak v té obci zůstane celou noc. Tak to je třeba ze 2 komínů znečištění. Když je těch komínů ještě víc, tak třeba celá ta obec, nevím, s 500, s 1000 lidmi, je po většinu večera a noci zahalena do takovéhoto kouře. A není to jenom obec. Třeba tohleto je záběr z Bulharska. Tohleto je lázeňská oblast Bansko. A z dálky my tam teda měřili vzduch, jednak v tom Bansku, a jednak 200 kilometrů daleko v sedle, v horském sedle od toho města. A to znečištění z toho vytápění těch domů proniklo takovým pásem prostě 200-250 km daleko. Takže to má opravdu už jako regionální charakter. Kolik si myslíte, že člověk prodýchá vzduchu za den? Na kilogramy. Vzduch je hmotný, že jo? Když se takhle uděláte rukou, tak cítíte, že se tam něco děje. No, kolik myslíš? No to ne, je to 20 kilogramů, což je stejně tak docela jako velká hmotnost. A když si to třeba srovnáte s tím, co pijeme, jo, nebo co jíte, a jak člověk dbá na tu stravu, prostě aby byla zdravá, a jak co pije, aby to byla minerální voda nebo bez škodlivin a tohle, tak kolik toho sníte, že pár kilo, kolik toho vypijete, kilo, 2 kila. A to, co prodýcháte, tak je 20 kg za ten den. Navíc ty plíce jsou měkká tkáň a zatímco v tom trávicím traktu to různě koaguluje, můžeme to vylučovat, tak v těch plících to jde, když jsou to ty částice menší než PM2,5, třeba PM1, PM2,5, tak jde přímo do krevního řečiště, čili do mozku, do orgánu. Jo, je tam třeba z toho znečištění z dopravy nebo z domácího vytápění, je tam prostě strašně moc polutantů, škodlivých sloučenin a 10 nebo 2 desítky z nich jsou kriticky škodlivé. A když jsme počítali teda takovou modelovou obec, jeden komín v údolní obci, která čítá 1000 obyvatel, dokáže to údolí té obce naplnit za pár hodin, za 5 hodin nadlimitní koncentrací škodlivin. A samozřejmě, když je 1000hlavá obec, tak to není jeden komín, který tam znečišťuje. To je třeba 30 komínů, které jsou fakt jako hustý na tu emisi. Ty PM2,5, jenom pro srovnání, ta velikost, jo, s tím třeba s lidským vlasem, PM10 jsou tyhle ty částečky, PM2,5 jsou tyhle ty malinký částečky a úplně nejškodlivější je PM1 a ty v podstatě se v plících nezadržují, ale projdou plícema do průdušnicí, průdušinkama do plicních sklípků a těma plicníma sklípkama rovnou do krevního řečiště a do orgánů. Jak takový polutanty vypadají, tohle je třeba z domácího vytápění, spalování, nekvalitní spalování pevných paliv, jsou to takové krystalky nebo nějaké prostě prachové částice a na nich jsou vidět ty škodliviny, které jsou nebezpečné. Takhle vlastně jako vypadá setřepaný vzorek z prachového filtru, který se používá na sledování kvality ovzduší. No k tomuhle já můžu říct, že you understand Czech, so I don't need to translate. Já jsem se účastnil pitvy, teda plící nebo jako kuřáka a při pitvě takhle rozřízli ty plíce, oni jsou černý, zdechtovatělí a ještě nám tak jako ostentativně ukázal, že ty plíce takhle zmáčknul a teda jako to je opravdu humus. To by se podle mě mělo ukazovat povinně, takhle během vzdělávání. Jo, a jsou tam třeba různý benzoapyrény, jsou tam škodlivý plyny ještě kromě těch pevných částic, benzoapyrén třeba, ale třeba jsme měřili chemické složení vzduchu v místech, kde jsme měřili v těch malých obcích a když se spalují odpadky, navíc nekvalitním jako spalováním za nízké teploty, tak třeba vzniká fosgen, což taky nepotěší. No, jak takový měření vypadá, tohle je tady šéf laboratoře kvality ovzduší na Přírodovědecké fakultě Honza Hovorka. Instalovali jsme takový semiprofesionální měřidla na střeše třeba chráněné krajinné oblasti pod Karlštejnem. Většinou třeba v té obci dáme 5, 10 a ještě chodíme nebo jezdíme s takovým vozejčkem, že se měří to znečištění v rámci té obce. A jak třeba vypadá graf, který z takových měření vzniká, tady vidíte, že to je 17:26, lidi začínají topit, to byl čtvrtek odpoledne, topěj, klesá to, zase klesá přes den a začíná pátek, odpoledne lidi zatopí hodně, přesáhne to kritickou hranici teda jako škodlivosti pro lidský zdraví vysokým způsobem a zůstává to během většiny noci, ta škodlivá koncentrace. Další věc, co jsme zkusili zajímavou, bylo, že jsme vzali ten měřák, vyšli jsme na Luční horu v Krkonoších a potom jsme ji dali na střechu auta a pomalou rychlostí jsme jeli až k naší kanceláři tady na Praze 1. A jak vypadá ten přejezd přes Českou republiku z Krkonoš do centra Prahy. Vyberte si jednu z těch line, to je jedno. Jo, tady byla ta Luční hora, čistý vzduch, já nevím, 4 mikrogramy na metr krychlovej. Jeli jsme na ski Alpech dolů, na sáňkách za sebou jsme jako vezli ten monitor. Tady jsme si jeli do Pece pod Sněžkou, tam už začaly vysoké koncentrace. A jeli jsme přes takové ty obce, co jsou u Turnova, Smržovka, tyhle ty vesničky a večer, když tam ty lidi zatápěli, tak ty koncentrace dosahovaly třeba 1000 nebo 1050 mikrogramů na kubík a limit je 40. Jo? Což je jako, to je vlastně jako strašně drsná koncentrace a ona tam zůstává, co máme z těch stacionárních měření, třeba prostě 3 týdny, když je inverzní situace. Třetí a poslední graf. Byl nějaký dotaz? Dotaz? Promiňte, já jsem zapomněl říct ten zbytek toho příběhu. Tady se najelo na dálnici. Dálnice je v podstatě čistá, protože ono bylo vlhko, takže tam nebyly ty prachové částice. Tohleto mírné zvýšení je tunel Blanka a kancelář už byla prostě zase nula v centru Prahy. No. To třeba, že se jelo opravdu nějakou údolní obcí, typicky třeba opravdu ta Smržovka nebo takový ty údolní obce tam pod těma Krkonošema, to je jako, tam v podstatě je nebezpečný už používat ten monitor, protože oni jsou takový blány a oni se to zanáší a musí se to pak rekalibrovat. To bylo jenom, to nejsou vědecký data, ten přístroj měří velmi přesně kalibrovaný jako na objektivní data, ale to bylo jenom jako, aby si člověk uvědomil, že prostě na horách je stejný vzduch jako v centru Prahy, což je takhle jako jednoduše prostě nějak takhle vizualizovaný, ale to, kde je problém, není ani Praha nebo velký města, kde lidi topí nějak kultivovaně, ale problém prostě jsou ty obce, který jsou takhle jako do těch třeba 5 000 obyvatel, kde se topí prostě nekvalitně starýma kotlema a špatnýma palivama. A ještě třetí a poslední teda graf, abych vás tady nezahltil. Zkoušeli jsme měřit ta zelená lajna nahoře, jsou venkovní koncentrace, PM 2,5, myslím to bylo. Ta zelená linka vodorovná je ta limita pro zdraví škodlivou koncentraci a ta růžová linka je vnitřní prostředí. U kolegy jsme měřili, který byl na dovolený zrovna 14 dní, takže tam měl jenom zavřený okna, nic tam nedělal, nebyl doma, nevětral, měl zavřený okna jenom na takovýto mikrovětrání. A je vidět, že ty vnitřní koncentrace sledují ty venkovní s nějakým zpožděním, třeba hodinovým. A třeba po většinu noci, i když jste doma, prostě spíte, tak když je venku špatný vzduch, tak vám to pronikne těma různýma porama u dveří a tím mikrovětráním povinným v oknech dovnitř a ráno se zbudíte, bolí vás hlava, prostě je vám blbě a je to z toho, že prostě celou noc jste vystavený stresu, z toho, že se musíte potýkat s takhle vysokým znečištěním. No a ještě úplně pro největší zajímavost, tady s kolegou, takovým fotografem Petrem Juračkou, se kterým jsme točili o tom film jako pro Novu, zkusili jsme vzít vzducholoď a proletět v Tušimicích přes ty výdechy té tepelné elektrárny, která topí uhlím. A kolik myslíte, že tam byla koncentrace přímo v té vlečce jako toho kouře? No, bylo tam třeba 600 mikrogramů na kubík, ten povolený limit je 40, ale v těch obcích je třeba 1500, 1500 standardní koncentrace. No tak když to pak těm lidem říkáme, tak jako jestli byste chtěli žít jako permanentně tady, tak samozřejmě ne, ale tady je to ještě jako třeba 3x lepší vzduch, než mají oni v obci. Jo, dá se to pak i docela dobře takhle třeba propagovat, když budete ve škole chtít dělat vzdělávací program ke kvalitě vzduchu, je to jako ožehavý téma, je to důležitý a různě se z toho dají psát potom různý články, dělat reportáže a tak. A proč to právě říkáme? ESA připravila ve spolupráci právě s kancelářema ESERO tenhle ten monitor na sledování kvality vzduchu, který si teda při odpolední workshopu ukážeme, který aktuálně teda ještě jako kalibrujeme tady, je tam přišroubovaný vedle profesionální stanice ČHMU, takže ty data můžeme poměrně dobře porovnat. A jaký třeba z toho vznikly data na Suchdole, kde to je vedle té profesionální stanice. Tohle je třeba zaznamenání kouře, který se dostal do Prahy z toho požáru v Českosaském Švýcarsku. 26. myslím, července to bylo. Takže až, já nevím, kolik to je, 100 kilometrů daleko, 80 kilometrů, Českosaské Švýcarsko, tak ten kouř se dostal do Prahy, byl i cítit tady a mohli jsme ho takhle naměřit tady takovýmhle jednoduchým monitorem. To jsou jako 100 000. Ale tam to je jenom jako odhad, ale to se vlastně ani neměří přímo když byste měřil výdech jako z komína, tak to by poškodilo ten přístroj, nebo by ho to rozkalibrovalo. To se odhadne, to jsou 100 000 miliony prostě. No a samozřejmě můžete se podívat zase na seriál Koumando, je v něm díl Topič, kde se děti potýkají tady taky se sledováním kvality ovzduší a s veřejnou diskuzí o znečištění. Dobře, tak to je všechno. To je v dopolední lekci závěr. Teď můžeme jít na oběd a odpoledne pokračujeme s workshopem na kvalitu ovzduší a na využití družicových snímků při sledování globálních problémů. Oběd je.
Tak já bych jenom ukončil tady tu dopolední část. Já bych poděkoval i studentům, že jste mezi nás dorazili. Doufám, že to bylo pro vás zajímavé. Ještě bych jenom jednou pro jistotu zopakoval, že nám přednášel o základech dálkového průzkumu Země pomocí družic Francesco Sarti, což je odborník z Evropské vesmírné agentury z Itálie. Děkujeme. Ještě tady někde krouží doktor Hlin, tamhle je. Což je odborník z americké univerzity a reprezentant americké NASA. A děkuji i Petru Marešovi za úvod do toho znečišťování ovzduší z České republiky. A protože těch nálepek NASA bylo málo a my ESA nálepek, nebo ne nálepek, ale těch sešítků máme víc a vlastně jste všichni jako bezvadně spolupracovali a vypadali jste, že vás to hrozně baví a zajímá, tak nakonec dostanete všichni něco od nás. Takže když tak pojďte sem s rukou odborníků převzít dárečky za vaši účast. Yes.